Okay, today we're going to finish up chapter 5, and that means that we review the next class, and then we take the test a week from Thursday. Okay, complex zeros. I want you to back up and let's go back to something that we had a second. The second class. Our old friend, the quadratic formula. Look at this. It says minus b plus or minus the square root of b squared minus 4ac. Okay, complex numbers are numbers in the form of a plus bi. Okay, so what we're saying is that if 3 plus 2i is an answer to our problem, then 3 minus 2i has to also be an answer to our problem. And the reason for that is right here. It's plus or minus the square root of b squared minus 4ac. So if the radical comes out with 2i, then I'm going to have a whole number plus 2i, and then I'm going to have a whole number minus 2i. Now keep that in mind. Complex numbers always come in conjugate pairs. If we know one of the answers, we can predict the other answer. So if minus 5 minus 6i is an answer, then I'm guaranteed that minus 5 plus 6i is an answer. Now I want you to notice, it doesn't change the sign of this whole number part of it. Minus 5 stays minus 5. It's the complex part, minus 6i. The conjugate of it is going to be plus 6i. So they always come in conjugate pairs. Another very important concept is this. Okay, an odd degree equation will have at least one real zero. It doesn't say that all three of them has to be, all of them has to be real. But it says that if I have any complex, any odd degree equation, it's going to have at least one real zero. A favorite one that I like to use for that right there is one just this simple right here. X cubed minus 8. Now, the real answer to that is easy to find. X cubed is equal to x. X is equal to the cube root of 8, which is 2. So the real answer to this, and it says that it has at least one real zero. So the real zero to this thing is 2. Now, let's review a little bit of that synthetic division and watch this next mess. So I got an x cubed. I need a place for x squared. I need a place for x. So this is 1. That's my place for x squared. That's my place for x. And then this is my minus 8. Now, we know that 2 is going to work. So we're going to use 2 with my synthetic division. 2 times 1 is 2. 2 times 2 is 4. 2 times 4 is 8. And just like we predicted, we got that. Now, look what we got left. We got x squared plus 2x plus 4 is equal to 0. Okay, this is my reduced quadratic. I'm going to do the quick way on this thing. This is real easy to solve by completing the square. You take half of the 2, which is 1, and you have squared, so I have 1 to both sides. So this gives me x plus 1 squared, and this gives me minus 3. So this gives me answers of minus 1 plus or minus I times the square root of 3. And the big deal is this. It had one real zero, namely 2. It has 2 complex zeros, minus 1 plus I times the square root of 3, minus 1 minus I times the square root of 3. Okay, so if I tell you that I got a third degree, and I give you one of the answers as 5, and I give you the another answer as 4 plus I, we can predict the third answer. And the third answer to this thing has to be 4 minus I, because they have to come in conjugate pairs. Notice that we said we were going to have a third degree. All right. Let's make a fourth degree. If I give you a fourth degree, and I give you one of the answers is 2I, and I give you one of the answers is 3 plus I, then the other answers has to be minus 2I and 3 minus I. They have to come in conjugate pairs. Okay, now we did one like this the other day. So let's find a polynomial and let me give you the roots. So suppose that I tell you that the roots are 3I and I tell you what, let's do third degree. And the other answer is 2. Okay, if I tell you that 3I is an answer, then minus 3I is also an answer. So what it says then is that x minus 3I is a factor, x plus 3I is a factor, and x minus 2 is a factor. Now, be careful when you multiply these. Multiply the 2 that have the conjugate pair in them first. So this is going to give me x squared minus 9I squared times x minus 2. You say, well, what happened to your middle term? Well, every time it's going to fall out. This is minus 3ix and plus 3ix. So it's x squared minus 9I squared. Now, remember one other thing. I squared is minus 1. So we can solve this now, and I get x cubed minus 2x squared plus 9x minus 18 is equal to 0. So this is our answer. This is the polynomial that would have those. Okay, you have one like this, so let's go ahead and follow through it. We're going to make a fourth degree and 2 plus I is an answer, which means that 2 minus I is an answer. And then I'm going to give you 3 with multiplicity of 2. In other words, I'm telling you that 2 plus I is an answer, 2 minus I is an answer, and 3 is an answer twice. So we've got x minus 2 plus I times x minus 2 minus I times x minus 3 times x minus 3. Now, I have to follow through with this because you've got one like this in your homework. It's a little bit difficult to keep track of, but we can do it. So we're going to follow this right here, and this is going to give me x squared. Now, my outside terms is going to give me minus x times 2 minus I. My inside terms is going to give me minus x times 2 plus I. And then my last terms are going to give me plus 2 plus I times 2 minus I. And then this is going to give me x minus 3 squared. Okay. Now let's try to clean up this mess. This is x squared minus 2x minus xi minus 2x minus 2x multiply this one again. Minus x times 2 is minus 2x. Minus x times minus I is plus ix. So this one's going to be minus 2x minus ix. And then this is going to give me plus 4 squared. And that's times x minus 3 squared. Now, that's why I was hesitating a while ago, because these x's has to go away. So this is going to give me x squared minus 4x. Now remember that I squared is minus 1, so I got 1 plus 4, which is 5. And then I multiply that by x squared minus 6x plus 9. Now I'm not going to take the time to multiply this out, but best thing to do is distribute the x squared, distribute the 4x, and then distribute the 5. Well, we've already worked a couple of problems like this. In fact, we might have worked this same problem. It's a favorite one for us to use. It's supposed to have 4 answers. Now, this is x squared times x squared, 4, 1, and everything is positive. So x squared plus 4 is equal to 0. X squared plus 1 is 0. X squared is minus 4. X is plus or minus 2i. X squared is minus 1. X is plus or minus 1i. So all 4 of the answers to this thing came out to be imaginary. Okay, let's go for a little bit of a different concept. And this is something called the intermediate value theorem. Now, we've already made the statement that every odd degree equation has at least one real root. Now, when it's an even degree equation, we're not guaranteed. In fact, the one that we just worked was an even degree equation, and it had no real roots. But I'm going to use this intermediate value theorem to show you really the power of graphing, what it can do, and just a little bit of our knowledge of using functional notation. So suppose that I wanted to find, say, the cube root of, or let's say 10. Well, if I were to draw this as a graph, when x is 0, y is minus 10. And when x is 1, y is minus 9. And when x is 2, better get this in perspective a little bit. 2, y is, no. When x is 2, y is minus 2. Now, when x is 3, I got 3 cubed is 27 minus 10 is 17. So when x is 3, y is 17. So I don't know where this graph turns, and it really doesn't matter where it turns. The important thing is this right here. When you draw this graph, look at it. When x was 2, y was negative. When x is 3, y is positive. So what that says then is that there has to be some number between x is 2 and x is 3 where the y would come out to be 0. And that's the whole concept of this thing. X is So if x is 2.5, I got 2.5 cubed minus 10. I'm going to cheat a little bit and go ahead and use the calculator on it. And that comes out to be 5.2. So when x was 2.5, my y value came out to be 5.62. Now, the important thing is this. I went from x is 2 to x is 2.5, and my y goes from a negative to a positive. So there has to be another x between 2 and 2.5 that would make this y 0. And we can just keep hemming this in. Let's try 2.4 this next time and see what happens. Now, it's amazing how close that comes out, because when I use 2.4, I'm going to have to exaggerate it right here. That comes out to be 0.002. So that says the answer is somewhere between 2 and 2.4. Now look how close this y value was to 0. So that means that my answer is very, very close to 2.4. So let's just cheat a little bit and let's just take 10 and let's find its cube root. It comes out to be 2.15. So I could back off a little bit more. I could have tried 2.3, and then I'd have got a little closer and a little closer. But the whole idea of the intermediate value theorem is that you find an x value that makes the y positive. You find the next x value find an x value that has the y negative. Find the next x value that makes the y positive, and then you just start squeezing it in through that. So this ends up our chapter 5, and this is the only one that we cover only one chapter and take a test. And I'll post the schedule for when we're going to do our test.